Hi guys, today I am here with a new video. In this video I am going to teach you Kepler's first law, another case. Here torque U is equal to R bar into F bar. Then RF into R bar into R bar cross F bar is equal to RF sin theta is equal to RF sin 180 degrees. Here small m is equal to mass of planet and capital M is equal to mass of sun. Here torque U is equal to 0 if angular momentum is equal to torque is equal to angular momentum is equal to constant, then mvr is equal to constant. Here force of gravitation is equal to g into capital M into small m by ra square. Gravitational potential energy of apogee is minus g into capital M into small m by ra. Gravitational potential energy of perigee is equal to minus g into capital M into small m by rp. Here gravitational potential formula is minus gm by r. Here we know that F is equal to dp by dt. Here dp by dt is equal to 0. Therefore F net is equal to 0. Then linear P is equal to constant. Then Pf by Pi is equal to Pf by Pi by T is equal to 0. Then according to law of conservation of energy, total energy of apogee is equal to total energy of perigee. Total energy of apogee we can write as kinetic energy of apogee plus potential energy of apogee. Total energy of perigee we can write as kinetic energy of perigee plus potential energy of perigee. Here potential energy we can write as U is equal to minus work done by conservative force. Here conservative force is gravitational force. We can write kinetic energy of apogee as half mva square minus potential energy of apogee. Here we have derived it. Gravitational potential energy of apogee is equal to minus gmm by ra. We will substitute in the equation and we will get half mva square minus gmm by ra is equal to, here potential energy of perigee we can substitute minus gmm by rp. We can write it as half mvp square minus gmm by rp. Here we can write it as va square by 2 minus vp square by 2 is equal to gm by ra minus gm by rp. By transposing the 2 that side, we can write it as va square minus vp square is equal to 2gm. Take gm common and we can write it as 2gm into 1 by ra minus 1 by rp. We know that va by vp is equal to rp by ra. Here vp is equal to ra by rp into va. We take va square minus vp square is equal to 2gm into 1 by ra minus 1 by rp as equation 1, and vp is equal to ra by rp into va as equation 2. Substitute equation 2, that is vp value, in the equation 1. There we get va square minus ra square by rp square into va square is equal to 2gm into rp minus ra by ra into rp. Therefore next we get va square into rp square minus ra square by rp square. Here is equal to 2gm into rp minus ra by ra into rp. Here one rp and another rp will get cancelled and we can write it as va square into rp minus ra by rp plus ra by rp square minus ra square. We can write it as rp minus ra into rp plus ra by rp is equal to 2gm by ra. Here already rp minus ra is there. We write it as like this and we get then rp, here rp minus ra will get cancelled. Here rp minus ra will get cancelled. Then we can write it as va square is equal to, we send rp by ra by rp go to right side. Then we get va square is equal to 2gm into rp by rp into 1 by rp plus ra. Here we know that rp is equal to a into 1 minus c, ra is equal to a into 1 plus c. Therefore rp plus ra is equal to 2a. rp by ra is equal to a by 1 minus c by a plus a into 1 plus c. A get cancelled and we can write it as 1 minus c by 1 plus c. And then here we can write va square is equal to 2gm into 1 minus c by 1 plus c into 1 by 2a. Then we can write it as va is equal to square root of gm by a into 1 minus c by 1 plus c. and Vp is equal to, similarly Vp is equal to square root of gm by a into 1 plus c by 1 minus here g is equal to gravitational constant, m is equal to mass of sun, and E is equal to eccentricity. Kepler's second law. It can also be denoted as law of areas. Radius vector joining sun and planet sweeps out equal areas in equal intervals of time. It is also called as aerial velocity of planet. It is constant here. Therefore, we can write aerial velocity as dA by dt is equal to constant. dA by dt is here in this diagram. The space A1 covered in t1 seconds and space A2 covered in t2 seconds by a planet. Here we can write it as A1 by T1 is equal to A2 by T2 is equal to constant. Here A1 is not equal to A2. A1 by T1 is equal to A2 by T2 is only equal. A1 is not equal to A2. dt, here dt is equal to small interval of time. A is equal to, here we can write it as, we can write A is equal to half into dl into r. We can write the area of the triangle. Here we form a triangle in this diagram. We can write it as here. So A is equal to half into dl into r is equal to half into dl into r is equal to half into, we can write dl as r d theta as we derived here. Dl is equal to r d theta. Then half into r d theta into r. dA is equal to, we can write here, we can write dA is equal to half into r squared d theta. dA by we divide dt on both sides, then we get dA by dt is equal to half into r square into dt by d theta by dt. Here aerial velocity is equal to half into, here we can write L is equal to mv, or we know that V is equal to r omega, then we can write m r omega into r. Here L is equal to m r square omega. Here omega is equal to angular velocity. Then we can substitute m r square omega in the place of L. Yeah, in the place of L. Here aerial velocity is equal to, we have got r square omega here. So by substituting r square omega as L, we can get A is equal to half into L by m. Therefore dA by dt is equal to L by 2m is equal to constant. Then Kepler's second law is a consequence of conservation of angular momentum. Here A1 is equal to A2 in this diagram. Here time intervals are same. Planets revolve around the sun with variable speed. Note, it is an important note here. V bar is equal to velocity vector of planet in this diagram. R bar is equal to radius vector of planet. Theta is equal to angle between V bar and R bar at any time t. dA is equal to area covered by radius vector in small interval of time dt. And here we get a triangle here, and we write and we draw it separately, and we can get dA is equal to half into, here we form a triangle. Here area of triangle is half into base and height. Here base is r and height is h. We can write it as dA is equal to half into r into h. Then dA is equal to half into r into dt into sin theta. Here dl is equal to distance covered by planet in dt. dl is equal to v dt, and we get it here. dA is equal to half into r into h. We know that half in h is dl sin theta. Half into r into dl sin theta is equal to half into r into v dt sin theta. Therefore dA by dt is equal to half rv sin theta. Therefore dA by dt is equal to half of modulus of r bar cross v bar. dA bar by dt bar is equal to half r bar cross v bar. If you like this video, please like, share and subscribe to my channel. Thank you for watching.